Good morning, all. Go ahead and throw something in the chat. Prove to me that you're here. Hello, hello. Hi, Riley. Good morning, Hunter. What's up? All right. Okay. There we go. Excellent. All right. Hey, hey. All right. Good morning. Hi. What's up? Anybody that has not checked in yet, please do so by throwing something in the chat. That would be great. Okay. All right. Got the blue behind me. I got everything set up. All right, cool. We are ready to rock and roll, guys. Somebody say something so I can make sure my audio is functioning appropriately. Literally anyone at all.
Hello.
Hey, there we go. I'm on a different computer today, so I needed to make sure that I actually had audio going today. All right. With that in mind, let's talk about what should already be done, what needs to be done. So let's see here. Share screen over here, rock and roll, and whoop, all the way to the top. Okay. So can everybody see the slideshow? Yes or no? Put it in the chat. Yes. YWA. All right. Yeah. Okay. So in this case, that should be way in the past. This should be way in the past. Bam. That should have been done Friday. That should have been done Friday. Yeah, that's due this morning. Yeah, addition, that's due this morning. This one is due Monday. What's today? Yeah, today's Monday. So this one should be due today. Very good. Now, hopefully everybody did this part and put it in with their assignment when they turned it in to Google Classroom. Does anybody see any of these here that you need help with? Did anybody need help with numbers 1, 2, or 3? Numbers 1, 2, or 3. Did you need help? Put it in the chat, folks. Yes or no? No, but I had a problem. Okay, what was the problem?
So when I went to go turn in my work, I went on the Google Slides.
Who am I talking to? Oh, Curly. Okay, yes, gotcha.
I didn't see the turn in button, but on Google Classroom, I found the multiplying and I turned it in there. Was that the right place?
That's a great question. Let me double check. Maybe I'm very oh, I did not put the little thingy there, did I? You just put it in polynomial multiplication?
Yeah, on Google Classroom.
That's fine. Now you will also put your Wednesday stuff in the same turn-in, okay? So you just add pages. Can we do that?
Yeah, thank you.
No, thank you. I should have put its own little thing there. So that's my bad. Okay. So, not a problem. Well, let's go ahead and let's talk a little bit about monomial multiplication, because everybody else was no, 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 no. Okay. So, with that, let's do stop share. And then let's do share again. And I want, actually, I'll just put it, I'll just throw it over here. All right, screen one. All right, can everybody see my mouse? Yes or no? Yes, okay. So we'll get the mouse out of the way. In the meantime, let's take a look at this problem right here. The challenge that a couple kids have emailed me about is when things have multiple variables in them. So let's think about this. This is pretty easy on its face. All I have to do is distribute this 3 times. Not that big a deal. But when I put these two together, how does that work? Well, let's see here. Times 4x. Well, all I really need to do is I need to take the numbers and put those together, negative 20. I have 2 x's here. I have 1 x here, so that's x cubed because I'm adding exponents. Remember, there's that sneaky 1 up there. I don't have any other y's, and I don't have any other z's. So there it is. That's all there is to it for that. Then I'm going to do the same thing over here. And I have 3 and negative 5 is negative 15. X squared is x to the 4th. Then I have y cubed and y is y to the 4th. And z, well, it's the only one. And then plus 10x squared y cubed z cubed. Okay. And of course, everybody, when you type in x cubed, that is the same thing as x. Shift with the 6, and that's your caret key, and then cubed. So, all right, is everybody cool with that problem? Excellent. Then everybody get out a piece of paper and do the following problem. Here we go. All right. I want you to multiply those two together. Go. All right, I'm going right down the list of people that I have. So Isaac, I need to know what is the first term times the first term. That's you, buddy. First term times first term. And then Bella, I need first term times second term. So this is Isaac, this is Bella. Then I need Aaron. Aaron, you are first term times last term. That's you. Then I need Morgan. Morgan is going to be second term times first term. Morgan. And then Hunter. is second times second. Riley is last times first. So there you go. That's who I need. Put them in the chat. Go. And Mia, we'll get to you later. So when you get your answer, put it in the chat. Okay, let's see here. What do we got? Oh, dun, dun, dun. Okay, I can't do exponents on here. It doesn't let me. Use the caret. So just like Morgan, put the caret, not Morgan, look just like Erin. There she is. So good job, Erin. All right. Hunter, I get what you're saying. Yes, 4 and 5 is their exponents. Okay. So here we go. Let's see here. Does Isaac have his answer in yet? Does Isaac have his answer in? No, he does not. I would say Isaac is having some technical difficulties today. All right. So Isaac's answer should be 18 x cubed y to the 4th. Then Bella says 12, I agree. X to the 5th, I agree. Y to the 5th, I agree. Then Aaron says 30x cubed y. 30x cubed y, I agree with her. And so then I need Morgan, 10x squared. Oh, yep, Morgan. 10x squared y. I agree with Morgan. Then Hunter, 4x to the 4th, y to the 5th. Yep. And then finally, Riley, So close, Riley. 2 times 3, because even though we're adding exponents, the numbers up front we're multiplying. So let's go with 6. And she says, okay, now I got an x here and an x here. So that's 1, that's 2. X squared y to the 4th, just like that. Because again, anytime you have x like this, it's like x to the 1st. Anytime I have y like this, it's y to the 1st, x to the 1st. There we go. So I got 1x here, 2x here, 1y here, 3y here, and that's what it should look like. All right. There we go. Now, by the way, you'll notice we did like boom, 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 and then I went boom, 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 only because that's why I lined them up. Since these are all plus signs, does it matter what order I put this whole thing in? Does it matter what order I put the whole thing in? Put it in the chat. Nope, you don't think so? Good job, Mia, and you are correct, because 2 plus 3 plus 5 is the same thing as 5 plus 2 plus 3. The order doesn't make a difference because addition can be moved all over the place. But just be careful that if there's any minus signs in there, that you move the negatives with the correct term. All right. So very good, guys. Very good. Now, let's talk about one more thing. We need to know what is the power of this polynomial. Now, this is weird because we have multiple letters. But here's the thing. The power or the degree is going to be the highest exponent term, which means for this, I put 3 and 4 together. That would be 7. Here I got 5 and 5. That's 10. I think that may be a good candidate for our biggest. 3 and 1, because there's that secret 1 there. That's 4. 3, 9, 6. Yep. Our highest one is this 5 plus this 5. So degree 10. There we go. Degree 10. So that is multiplying. All right. Let's do one more thing here. Actually, 2 more things technically. The 2 things that we have to do to finish this up is we need special products. Now, special products are really nothing fancy. All they are is the same old multiplication. It's just they find themselves in 2 types, A plus B, which means it's the same thing as saying A plus B squared. All it means is I multiply something by itself, and there's only 2 pieces to each. The other one, so this is a perfect square. The other one is A plus B, A minus B, and that is called a difference of squares. And here's why. Here's why. If I put this together, what is A times A, ladies and gentlemen? A times A. Put it in the chat. A times A is A squared. Very good. Hey, how'd you get the little, how'd you get the little squared, Mia?
I just press the caret button with the shift and then I press squared.
There we go. All right. Very good. So A times A squared. A times B is AB. Almost did it. A times B would be AB. Then I got plus BA, which is the same thing as AB. And then I have B squared. So the perfect square means I have A squared and B squared up front and back. And in the middle, what's the middle term going to be? What goes in this spot right here, ladies and gentlemen? What goes in that middle spot? Ooh, it's not AB squared because we're adding two pieces. So if I have one AB here and another AB here, together I simply have two ABs because I'm adding them, not multiplying them. Why did this go to A squared? Because I multiply A times A squared. Why did I have AB? Because I said A times B, but when I just add them up, 2AB. Likewise, I got A times A is A squared. Then I have A times negative B would be negative AB. B times A, so plus AB. And B times negative B is negative B squared. So I get A squared and I get B squared. What goes in the middle, folks? What happens to negative AB and positive AB? Negative AB plus positive AB. What happens if I have negative 4 plus 4? What is negative 4 plus 4? They cancel out. I agree. So guess what? When I have a negative AB and a positive AB, they're gone. So I just have A squared minus B squared. The reason these are called special products is because they happen to show up over and over and over and over again. So let's do two problems just like it. X plus 4, X plus 4, go. And 2x minus 3, 2x plus 3, go. Do those two problems right now. All right. What should I get for the first answer? What should I get for the second answer, folks? X times X is X squared. X times 4 plus 4X plus 4X plus 16. So if I have my little marker here, I go X times X, X times 4, 4 times X, 4 times 4. Final answer is X squared plus 8X plus 16. Then over here, 4X squared plus 6X minus 6X minus 9. What happens to those two middle terms, folks? They gone. Yeah, they cancel out. Very good. Okay. So that is special products, which is really, it's not any different. They just happen to be specific versions of multiplying, but it's still multiplying. So one thing about it is nothing terribly challenging. Please, when you're doing your ed puzzles, be a little bit more careful, because some of you, I think, just kind of halfway schmutz it up and then have it reset just to do it again. just kind of make more work for you and me. So when you go through the ed puzzles, listen carefully because they're intended for you to be able to get the questions right the first time. Okay. I don't mind resetting them. Keep bringing on the emails, but just work a little harder at it. Okay. All right. Now that brings us to what does the future hold? Well, let's see here. This is due Wednesday. That is due Wednesday. So those two pieces are due Wednesday, which you already knew. What I've decided is instead of going into factoring yet, let's wait. And I'll just get rid of that. And actually that one may be okay. So what we're going to do is special products. And then that means that due Friday is a practice test. So Wednesday, I'm going to assign you the practice test for this first half of the chapter. And then by Tuesday, you have to have the full test done. So basically what we're going to do is we're just going to have a test on just these 10 slides. Okay. So what is polynomial? Vocabulary for polynomial, add, subtract, multiply. That's it. It's going to be an easy way to start the semester, get some good grades in the book. Okay. So these are not live yet, but they will be in the next hour. So you will see those, and those will be available for you to work on within the next hour. So practice test will be due Friday, real test on Tuesday. In the meantime, you have multiplication due Wednesday and special products due Wednesday. Any questions? If not, I will catch you later, guys.